8.2a, the substitution method. This is substituting for a variable for a system of equations. So graphing to solve a system of equation has one serious disadvantage. It's difficult to find an accurate solution for an ordered pair like 1/3 for x and -5/6 for y, because their point isn't exactly on crossing grid lines. One way to solve for this ordered pair would be to use the substitution method. This method is really useful if one equation is already solved or can be solved quickly for one of the variables. And if the values are rational numbers, fractions, or decimals instead of integers, counting numbers, then the substitution method will help. So we can solve a system of equations by substituting a value from one equation into the second equation. If we have x plus y equals 6, and our other equation is x equals y plus 2, well, if x is equal to y plus 2 over here, then we'll just use y plus 2 as x. We'll plug it into this equation in place of the x because it says x is equal to that, right? So we can make it represent that. So instead of the x, we put the y plus 2 that this equation says it is. So now we've got y plus 2 plus y equals 6. Well, that means we've got 2 plus 2y equals 6. Now, all we have to do is subtract 2 from each side, and that'll help us solve for y, won't it? Because this will create a zero pair. It'll be eliminated, and now we've got 2y is equal to 4. Now all we have to do is use identity property, get our friend the invisible 1, and we'll divide both terms on each side of the equation by this coefficient 2, and we get y is equal to 2. Well, now we know what y is. We know y is equal to 2. Now we can plug y equals 2 into this equation to really find out what x is. So in x equals y plus 2, we put the 2 where the y is. See? And 2 plus 2 equals x, so x equals 4. So now we take both equations and we take x equals 4 and y equals 2, and we plug them into both equations to see if it makes them true. And 4 plus 2 equals 6, yep. 4 equals 2 plus 2, yep. So our solution, our ordered pair, is 4 for x and 2 for y. See? So we solved it by substituting one value, and it was a pretty big one, right? Because it was a y plus 2 that we plugged in for x. All right, now watch. If we've got our equations x minus 2y equals 6, and our other equation is 3x plus 2y equals 4, well, we solve the first equation for x, this one. And because this one's got too much going on, so this is a simpler one, we're going to solve this one for x and then substitute the 6 plus 2y to represent x into this equation. So solve it for x, because x is already by itself, so this is a minus 2y. Let's add 2y to both sides of the equation. So that means x is equal to 6 plus 2y. So now we're going to use this to represent x in this equation. So that means we've got 3 times 6 plus 2y plus 2y equals 4. And we use the distributive property, right? And we get 18 plus 6y plus 2y. Now we simplify it by combining like terms. A 6y and a 2y makes an 8y, doesn't it? And now we can solve it for y by subtracting 18 from each side using additive inverses. We know that's going to create a zero pair here, right? And eliminate that. So now we've got 8y equals negative 14, because positive 4 take away 18 is a negative 14. Now we can divide both terms on each side of the equal sign by this coefficient 8. It's going to be identity property, give us our friend the invisible 1. Can't really see him in front of here, but he's there, isn't he? So now we've got y is equal to negative 7 over 4, because that's what that simplifies to. So now that we know that y is equal to negative 7 over 4, we can plug that in to the first equation, which was x minus 2y equals 6. So now we can put this in for y, negative 7/4. So now we've got 2 times negative 7/4 instead of 2 times y here, don't we? And a negative times a negative makes a positive, so it's going to be positive 14 over 4. Because there's like a little 1 here, isn't there? So it's 14 over 4. All right? So now that can be simplified to 7 over 2, can't it? So now what we can do is subtract 7/2 from each side. And 7/2 is like 3.5, isn't it? We can also write the 6 as a fraction that's equivalent to having a 2 as a denominator. So instead of 6 over 1, it would be 12 over 2. We can do 12 over 2 minus 7 over 2. And that would give us 5 over 2. See? So now we know that x is 5/2 and y is negative 7/4. That's the solution to our system of equations. We can check it by plugging these values into the equations. And we get 5/2 minus 2 times negative 7/4 equals 6. Well, that means we've got 5/2 plus 7 over 2, because it becomes 14 over 4, which simplifies to 7 over 2. And that gives us 12 over 2. That's a 6, isn't it? So 6 equals 6. And on this side, we get 15 over 2 minus, because that's a plus and a minus, it gives us a minus 14 over 4, which simplifies to negative 7 over 2. 15, take away 7 is 8, and we slide the 2 over, don't we? And 8 over 2 is a 4, so 4 equals 4. So yes, by checking it, we know we did it right. So always remember to check your work in case we made a mistake. If we do a slight little math mistake of a plus sign or a minus sign, or we don't simplify correctly, we could end up getting the wrong answer. And if you're taking a test, I guarantee you a lot of these tests will purposely put a tricky answer that looks like that's what it could be if you make a mistake. Like it'll say, you know, if the answer is supposed to be a negative 6, they'll give you the option of a positive 6 to trick you. So that if you did some bad math, you'll end up filling that one in thinking it's one of the options. So be very, very careful of your signs. Be very careful when you're doing these rational numbers, these fractions, to make sure you're simplifying correctly. All right? So our next video is going to be 8.2b, and it's more systems of equations, and we're going to talk about solving word problems by substitution. And if you want links to identifying solutions or solutions by graphing, those were our last couple of videos, or how we did a proof of slope m, or parallel or perpendicular lines, those links will be in this description. And I'm going to put a link to my Grade 8 Math Systems of Equation playlist, because a lot of what we're talking about is going to be in the Grade 8 Math Systems of Equation playlist. And I'll explain things a little bit differently with maybe some different examples. So it'll be a little extra help for you, because the Grade 8 Math is Algebra I. Okay? I hope you're doing okay. I'll see you next video. Keep trying. I believe you can do this. Bye.